Today we are going to begin Lesson 1.3, Evaluating Functions. Take a moment to go ahead and write down today's objective. You're going to write down, I will be able to evaluate functions, and we will be finding the domain and range of real-life situations. Take a moment. As soon as you have the objective written down, move on to the next slide. We're going to begin with looking at function notation. When you see it written with f next to x in parentheses, the way you're going to actually read it is f of x. So the way you would read this function out loud would be f of x equals 2x plus 4. If we want, we can change and replace the f of x with a y, and it will also make a linear equation. Both f of x equals 2x plus 4 and y equals 2x plus 4 are the same line should we decide to graph them. So f of x equals and y equals are the same thing. Please keep in mind that x is always going to be your independent variable. So let's take a moment and look at some examples where you're going to evaluate each function for the given value. This up here says f of x is equal to negative 2x plus 5. We want to evaluate it for f of 7. So here's what I would like to see on your papers when you show your work. Anywhere there is an x, you're going to set up an empty set of parentheses, and then we will go back and sub in that value of 7. So now, using your order of operations that we just reviewed, multiplication comes first. So you will have negative 2 times 7 is negative 14 plus 5. Then you will finish simplifying. Negative 14 plus 5 is negative 9. In order to look educated, you're going to come over here and have your answer look official. We will say f of 7 is equal to negative 9. That means when I have a function where x is 7, my answer, my solution, is negative 9. This is what I would expect your homework in your paper to look like when you are evaluating functions. Take a moment when you are ready and go on to the next question. Set it up, and then when you finish, unpause the video and check to see how you did. Okay, so take a moment and check and see how you did. Over here, you will notice that I subbed in the negative 2 where there was an x. According to order of operations, I would multiply first. Negative 4 times negative 2 is 8. I rewrote the plus 1. Nice and easy, 8 plus 1 is 9. Your official answer would say f of negative 2 is equal to 9. If you've made any mistakes at this point on these two problems in your notes, I'd like you to take a moment, go back and correct them so that you have an accurate record within your notes. When you're ready, move on to the next slide. Here is another example. We are still doing the same process where we are going to sub in the value. We are going to evaluate for f of negative 3. So that means anywhere there is an x in my function, I am going to put an empty set of parentheses, because inside that is where I'm going to sub in the negative 3. Especially the fact that we are working with negative numbers, I want you to be very careful with your signs. So here's the negative 3 being subbed in for this x. And here's the negative 3 being subbed in for this x. Now, order of operations says to start with parentheses. Remember from the last lesson, this is not a problem inside parentheses, so it does not count. The next thing we look for is exponents. So you will notice we have negative 3 squared. That means I have the number negative 3 2 times. So that is negative 3 times negative 3, which is a positive 9. So you will notice after I write the positive 9 that I am rewriting everything else. I am not trying to do more than one step per line. Now, according to order of operations, the question is, should I add, multiply, or subtract? I'm hoping you said multiply. So if I multiply 2 times negative 3, that answer is negative 6. So I now have 9 minus 6 minus 5. Now we both have two subtractions. We're going to go in order from left to right. You have 9 minus 6, which is 3. And then 3 minus 5 is negative 2. If you remember from our conversations with our warm-up, the larger number is negative, which means our value needs to be negative. So our final answer is going to look something like this. F of negative 3 is equal to negative 2. That means when I sub in a value of negative 3 for the x, the solution was negative 2. Take a moment, make sure you have all the work shown just as you see on here, so that when we check your notes in class, it will match. When you're ready, come over here and try and do the same problem, but sub in 1 for your x. When you're done, unpause the video and check yourself. All right, so how did you do? When you came over here, did you sub in the 1 for the x here? And did you sub in the 1 for the x here? Once you have that done, you would begin with the exponents first, because there are no parentheses with an actual problem inside of it. So 1 squared, 1 times 1 is 1. Notice I rewrote the plus 3 times 1 and the plus 2. Next, multiplying comes before adding. So we're going to multiply 3 times 1, which is 3. So now I have 1 plus 3 plus 2. Well, we can do that in our head. 1 plus 3 is 4. 4 plus 2 is 6. So our final solution should be f of 1 is equal to 6. Once you have both of these problems down, go ahead and move to the next page. For our last two examples, we're going to continue subbing in to evaluate the functions. The difference here, when you sub in for x, it is not going to be simply just a number. For example, here we are solving for f of 3x. So that means when you are subbing in for the place of x, you are going to sub in 3x here. When you get ready to multiply, 4 times 3x, you're going to multiply your numbers. 4 and 3 is 12. And then you're going to attach the x. That is the same as saying you have the term 3x 4 times. So 3 plus 3 plus 3 plus 3 is 12. There's our 12x. And then we will write minus 6 behind it. Now please notice these are not like terms. The 6 does not have an x attached to it, so we cannot combine these two terms. We are actually already done. The way your final answer should look is f of 3x is equal to 12x minus 6. That is as far as we can simplify it at this time. Take a moment, set up number 6 over here, and then pause the video and see if you can distribute the 2 correctly and then combine like terms. When you have this problem finished, unpause the video and check yourself. So when you take a moment to check yourself, were you able to get to the final solution of f of x plus 3 is equal to 2x plus 11? Let's take a moment and look and see how we got there. If you made any mistakes, now is a great time to erase and make some corrections. When we see a 2 sitting next to parentheses, we are going to distribute. 2 times x is 2x. 2 times 3 is 6. Once we reach the end of the parentheses, we are done distributing. I am not going to distribute the 2 to the 5. The 5 is not in the parentheses. We simply write it down here below. When I look, I have 2x plus 6 plus 5. Which two terms are like each other and can be combined? I'm hoping you were saying the 6 plus 5. When I combine that, I end up with 2x plus 11. They are not like terms, so they cannot be combined. That is our final answer. When you are complete with both of those questions, go ahead and move on to the next slide. Now we're going to come back and revisit domain and range. We're going to look at situations in the real world setting. Just like I told you the other day, we are going to be looking at domain and range throughout the entire year. It's going to show up lesson after lesson. Let's take a moment and look. The dance committee here at O'Connor is selling tickets to the dance. The more tickets they sell will increase the amount of money they can spend for their decorations. What I'm asking of you here is which would be the domain and which one would be the range. Well, let's take a moment and look. In the story, we are talking about two different things. We're talking about the number of tickets we sell, and we're talking about the amount of money. So the question is, which one is the independent variable, which would be your domain, and which one is the dependent variable, which would be your range? Just a quick reminder from 1.2, domain is your x variable and range is your y. The way I like to look at these is answer the dependent one first. Which one depends on the other? Does the amount of tickets sold depend on how much money they make, or does the amount of money they make depend on how many tickets they sell? So we're going to go with the amount of money made depends on the amount of tickets they have sold. So our dependent variable, which is our range, is the money that is made. That makes our independent variable the number of tickets. So you are just simply identifying which one is independent and which one is dependent. I would like you to make sure that you are copying down not only the answers, but you are writing the short little problem here about the dance committee selling tickets. Then you're writing domain and calling it the number of tickets, and range, the amount of money made. The next example we're looking at is the air pressure inside of a tire increases with the temperature. So if you've ever driven in the Arizona heat, think about that for a moment. Which depends on the other? Does the pressure inside the tire depend on the temperature, or does the temperature depend on the pressure inside the tire? You definitely see evidence of this in the real world when you are driving on the freeways here in Phoenix, Arizona, when the pressure inside the tire gets too much and the tire explodes and you see pieces of the tire all over the freeway. So what did you decide? Which one depends on the other? The pressure is dependent on the temperature. The hotter it gets, the more pressure there will be inside a tire. So make sure you have written down the story as well as the domain versus the range. Okay, next example. We want to compare the amount of rain is decreasing as the water level of the river. So as the amount of rain decreases, so does the water level. So we're talking about the amount of rain, and we're talking about the level of the river. Which one depends on the other? The level of the river, how high the amount of water is. The level of the river is dependent on how much rain there is. So that is all I'm asking you to do, is identify the domain and range, which is also the independent versus dependent. Okay, next one, we're going to look at setting up the equation and then use our evaluating skills. Julie's mom gave her $200 for her lunches. She spends $10 each week. We're going to go ahead and write a function in the correct notation that describes the amount of money, M, that Julie has over time, T. Let's identify the domain and the range. Which one is dependent on the other? I'm going to say the amount of money Julie has is dependent on the amount of time that has gone by. So I'm going to identify domain as time and the range as the amount of money. If we want to write an equation to represent that, the amount of money over time is equal to, well, Julie starts with $200. If she is spending her money, should we add or subtract what she is spending? You definitely do want to subtract it. And she is spending $10 per week. So that's going to be $10 times the number of weeks that goes by. So you would write that as 200 minus 10t. The reason I had you set up that function there is now you're going to come down to question A. We're going to evaluate the function for 12 weeks' time. So here's how you're going to set this up. The amount of money after 12 weeks, which would be called M of 12, is equal to 200 minus 10 times, and I'm going to sub in for this t, I'm going to sub in the 12 because we now know time is 12 weeks. According to my order of operations, I am going to multiply first. 10 times 12 is 120. So now I have the 200 minus the 120 she spent, leaves her with a balance of $80. So the money remaining after 12 weeks, M of 12, is equal to $80. So the next question that applies to Julie here is, after how many weeks will she be out of money? There are many ways that you can go about solving this. I would like you to take a moment and solve it. Pause the video. When you're done, come back and check your answer. So were you able to figure out that it would take Julie 20 weeks before she runs out of money? There are many ways you could have solved this and shown your work. I'm just going to show you one example. I took the original function, m of t equals 200 minus 10t. Instead of m of t, I wrote a 0 here. She will run out of money when her balance is 0. So then to solve it, I added the 10t to the other side. So I have 10t is now equal to 200. Divide by the 10, and 20 divided by 10, or 200, excuse me, divided by 10 is 20 weeks. There are several other ways you could have solved this. If you saw after 12 weeks over here that we had 80 left, the question is, how many more weeks can you go with $10 a week with your $80? That would be 8 more weeks plus the 12 is the same answer of 20 weeks. I do not care how you solve it, as long as you have some way of justifying your answer. Okay, last question. We're going to look at George, who has won a raffle. He has received $2,000. He has decided to go ahead and save his money. He also wants to earn more, so he's going to make $15 per hour working at the bank and save that as well. We're going to write a function in the correct notation that describes the amount of money, M, that George has in terms of time. We're going to look at the domain and the range. What is dependent on the other? Is money dependent on the time, or does time depend on how much money we have? I am hoping you saw that the amount of money we have is dependent on the amount of time he spends tutoring. So if I were to come over here and write the function, the amount of money that George has after the hours worked is equal to, he does have his $2,000 to start with, plus he is going to earn $15 per hour, so 15 times the number of hours that he works. Notice here we are adding instead of subtracting because he is adding to his account, not subtracting. The next one is we want to evaluate how much money he will have after 23 hours. So just like the beginning of your notes, we're going to take a moment, and where the variable is the h, we are going to sub in the 23. We are then going to multiply first, because in order of operations, multiplying comes first. 15 times 23 is $345. You can either calculate that on your calculator, or you could write it by hand on your paper. Final straw, we're going to sit here and add the 2,000 plus the 345. And we will find that the money after 23 hours, which is M of 23, is equal to $2,345. So take a moment, make sure you have all the work to support that answer. The next question is, how many hours must he work to have 2,800? Well, that means I want his money, the 2,800, to be what he has. The question is 2,000 plus 15 times how many hours will it take? Well, let's think about that. If he wants 2,800, but he already has 2,000, he really only needs to save up another 800. That is why we are subtracting the 2,000 from both sides. So now we have 800 is equal to 15h. So the only problem we really have to solve here is 15 times what number is 800. We can guess and check by multiplying, or we could just divide by 15. So the number of hours that George needs to work to equal his $800 is 53.3, where the 3 repeats. Now, since this is a real life situation here, we're going to go ahead and say that the number of hours that he needs to work would be 54 hours. Okay, that is it for our notes today on evaluating functions.